welcome back to School Coaching Point. So today we will discuss one important question from continuity and differentiability of class 12. So here is the question. Find a and b if the function is given by fx equals to ax square plus b if x less than 1, 2x plus 1 if x greater than equal to 1, differentiable at the point x equals to 1. So here it is given that the function is differentiable at the point x equals to 1, and we know one result. If a function is differentiable at a particular point, suppose here it is x equals to 1, then it must be continuous also at that particular point. So this is the one of the important result we need to use to solve this kind of questions. So here the function is differentiable at x equals to 1. So we should write given fx is differentiable, at x equals to 1, therefore fx must be continuous at x equals to 1. So this is the result we need to use to solve this kind of question. Here it is given the function is differentiable at x equals to 1. It means it must be continuous at the point x equals to 1. And we know that if a function is continuous, it means the left hand limit is equals to right hand limit is equals to value of the function at that particular point. That means we can write limit x tends to 1 plus, that means the right hand limit is equals to limit x tends to 1 minus, that is the left hand limit is equals to the value of the function. So this is the condition for continuity. Now limit x tends to 1 plus fx. So 1 plus means we need to consider all the values of x which is greater than 1. So x is greater than 1, that means this is the condition. So fx equals to, we should write 2x plus 1. So here it is x tends to 1 plus, so x should be greater than 1. So this is the condition. So 2x plus 1 is equals to limit x tends to 1 minus. So 1 minus means the values of x should be less than 1. So this is the condition. So fx should be replaced by ax square plus b, and f of 1 means x should be equals to 1. So here is the condition. X equals to 1 means this is the function 2x plus 1. So 2x plus 1 replacing x by 1. So 2 into 1 plus 1 is equals to 3. So from here limit x tends to 1 plus 2x plus 1, it means 2 into 1 plus 1. Limit x tends to 1 minus ax square plus b, it means a plus b is equals to 3. So 3 equals to a plus b is equals to 3. So we can write a plus b is equals to 3. So using the condition of continuity, we get this result a plus b equals to 3. So suppose give it equation 1. Now let's move to the next part. So here the function is differentiable. So if the function is differentiable at the point x equals to 1, so what is the condition? We know if a function is differentiable at that point x equals to 1, it means the left hand derivative L f dash 1 should be equals to R f dash 1. Now we have to find out L f dash 1 and R f dash 1. So L f dash 1 we have to find out now. So L f dash 1, that means the left hand derivative. So limit h tends to 0 f of 1 minus h. So why it is 1 minus h? Because we are finding the left hand derivative. That means we are approaching 1 from the left hand side. That means we need to take the values of x which is less than 1. That's why it becomes 1 minus s. So it becomes f of 1 minus h, then f of 1 divided by minus h. So limit h tends to 0. So f of 1 minus h. So which condition? So this is the condition we need to use, because here we are taking 1 minus h. That means the values of x should be less than 1. So here is the condition, ax square plus b. So f of 1 minus h should be equals to a 1 minus h whole square plus b, and f of 1 means, so here is the function 2x plus 1, so 2 into 1 plus 1. So limit h tends to 0 minus h a 1 minus h whole square plus b minus 3. Limit h tends to 0 minus h. So here we can use the identity a minus b whole square. So it's 1 square means 1 minus 2ab 2h plus h square, using the identity a minus b whole square plus b minus 3. So from here limit h tends to 0 minus h, so a minus 2ah plus ah square plus b minus 3. So you can write limit h tends to 0 minus h a plus b minus 3 minus 2ah plus ah square. Now here we can see that we cannot replace the value of h by 0, because here we get the another term a plus b. Now in the previous result we get a plus b equals to 3. So it was equation 1. Now from this equation 1 we can easily replace the value of a plus b in this equation. So here we can easily replace the value of a plus b. So a plus b we get is equals to 3. Now from here limit h tends to 0, a plus b means 3. So 3 minus 2ah plus ah square divided by minus h. So these 3 we can cancel. So from here limit h tends to 0 minus h, so minus 2ah plus ah square. Now from here limit h tends to 0, so you can take common h from these two terms. So taking common h, it becomes minus, or you can take common h, it becomes minus 2a plus ah. Now you can cancel these two, h. So it becomes limit h tends to 0 minus 2a plus ah. So after putting the value of h we get plus 2a. That means left than limit, so left than derivative is equals to 2a. So left than derivative we get 2a. Now we have to find out the right hand derivative. So how can you find out the right hand derivative? So left than derivative, how much we get? Left than derivative we get 2a. Now we have to find out the right hand derivative. So right hand derivative, so here is the formula. So limit h tends to 0, f of 1 plus h minus f of 1 divided by h. So why it is f of 1 plus h? Because we are finding the right hand derivative, so it should be greater than 1. So f of 1 plus h, so we need to take the value of x which is greater than 1. So this is the condition. So limit h tends to 0, f of 1 plus h means 2, replacing x by 1 plus h, 1 plus h plus 1, and f of 1 means it's 3. So limit h tends to 0, 2 plus 2h plus 1 minus 3. So you can cancel. So limit h tends to 0, 2h by h. So this h cancel. So here it becomes 2. So right hand derivative, how much we get? It's 2. So twice a equals to 2. So right hand derivative is 2. Left hand derivative we get twice a, so from here 2a equals to 2, so after simplifying a equals to 1. So here we get a equals to 1. Now we have to find out the value of b from this equation 1. A plus b equals to 3. From here just simply replace the value of a equals to 1. 1 plus b equals to 3. From here b equals to 3 minus 1 is equals to 2. So this is the solution of the given question, and one thing you should remember, this kind of question we need to solve by using the concept of continuity. So I already told you, if a function is differentiable at a particular point, then it must be continuous at that particular point. So using this concept, we have to solve this kind of questions, and in the next video I will bring a few more important questions from the topic continuity and differentiability. Now, thank you.